All right, I want to continue with verifying identities. So example 7 says, change to sines and cosines. So we're going to start with the left-hand side. And this problem's going to get a little long, so I'll be using the full screen. So one thing we can do is use our identity that I just highlighted here in the yellow for the sine of negative x equals negative sine of x. So that's one of the even and odd identities. So I'm going to replace that yellow piece with negative sine of x. Now when we simplify the numerator, we have a negative and a negative. Well, that's going to turn to an addition symbol. Now we're going to change this tangent of x using our quotient identity to sines and cosines. So the quotient identity for tangent of x says we have the sine of x over the cosine of x. And then this is still the sine of x all over 1 plus the cosine of x. Now, in the numerator, we have this cosine of x, and we want to combine those two fractions together. It doesn't look like it's a fraction right now, so we're going to put a 1 in the denominator. Now we need to find the LCD of those two denominators. So right now I have a cosine of x and a 1, and I want them to be the same. So we want to find the LCD. So we're going to multiply by the cosine of x here and the cosine of x there. Now the two fractions are alike. So we can combine them together into one fraction. So I have the sine of x plus the sine of x, cosine of x, over the cosine of x, and then it's all over 1 plus the cosine of x. All right. From there, we can think about fractions dividing by fractions. So I'm going to change this to a fraction. So now I have a fraction dividing a fraction. So we're going to keep that fraction. We're going to change this division symbol to multiplication, and then we're going to flip that bottom fraction. So I'm going to go up to the top here. So we're going to keep the sine of x plus the sine of x, cosine of x, over the cosine of x. And we're going to change that division symbol to multiplication. And then we're going to flip 1 over 1 plus the cosine of x. All right. What we can do next is take out the greatest common factor. We have a greatest common factor with the sine of x in that first fraction's numerator. So we're going to take out a sine of x, and we're left with 1 plus the cosine of x, and then cosine of x. Second fraction, we're just keeping it the same. Now, looking at those two fractions, there is a common factor. What is that common factor? That common factor is a 1 plus the cosine of x. So those can cancel out to 1. Now we have the sine of x over the cosine of x. And then our last step is to use our quotient identity, which is the tangent of x. So we have now proven that these are identities.